How y'all doing? We're going to correct the mistakes we had in 7th period class. Who were sharp enough to notice that when we drew SO3 and found there were 6 valence electrons for sulfur, 3 times 6 is 18 for oxygen, which gives us 24. And then we proceeded to draw it, and it looked like this. Like this. And we started putting our dots around, like so, like so, like so, like so. And then we counted them. We counted them. Use a different color here. So we had 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. That will not work. We need 24, so I'm going to take all those off. And I'm going to change this, take this away, and make a double bond here, which means I'm going to have to take this other one away, this right here. So now we have, let's count them again, 2, 4, 6, 8 around oxygen. We have 2, 4, 6, 8 around sulfur. We got 2, 4, 6, 8 around that oxygen. We have 2, 4, 6, 8 around that oxygen. Okay, wonderful. Now let's see if we have, well, delete, 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 please delete. Okay, we'll do this way. Okay, so now we have this, oh, sorry, let's go back to purple, boom, delete, boom, okay, there, there, there. Okay, so let's see if we got enough. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Whoop, whoop. We have it. But here's what the other class was saying. If you look over here, that oxygen has 1 extra electron in its valence shell because you're seeing 1 electron, 2, 3, 4, 5, 6, 7. So that gives that a minus charge. Well, guess what? If you look at this one, you have 1, 2, 3, 4, 5, 6, 7, which also gives that a minus charge. This one up here, on the other hand, has shared 2 electrons, which is exactly what you would expect. You do need 2 more over here, though. Right there, to make 8. But then we get into the sulfur problem. We come in here to this. The sulfur has 1, 2, 3, 4 electrons, and it should have 6 because it's 6 valence electrons. So that gives that 2 short of the valence electron, so it has a plus 2. So if you take this plus 2 and this minus, it gives you a net charge of 0. Therefore, this drawing is correct. Are you seeing this too? Perfecto. Let me hit that one more time. We're going to draw it again. Sulfur in the middle. Sulfur in the middle. Boom. Oxygen. 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 Got a double bond there. Dot, 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 dot. 2, 4, 6, 8. Dot, 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 dot. 2, 4, 6, 8. Over here. Dot, 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 dot. 2, 4, 6, 8. So we're good. So we count them up. We got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Hooray! Perfect number of valence electrons. So now, what's up with this? We're going to use green. We have 1, 2, 3, 4, 5, 6, 7 electrons in the outer shell of oxygen, which it's only supposed to have 6. So that gives us a -1 charge there. We look over on this one, we have the same thing. 1, 2, 3, 4, 5, 6, 7, which is a -1 on that. This one up here on the top right, we have 1, 2, 3, 4, 5, 6. Whoopsie, I did it again. We need 2 here. So we have 1, 2, 3, 4, 5, 6, 7, 8. And these 2 right here are shared. So we have 6 valence electrons and 2 are shared to give it 8 in the octet. Now, let's look at sulfur. Sulfur has 1, 2, 3, 4 electrons. It should have 6. So it's missing 2 electrons, which gives it a +2 charge. So now we can see that the net charge +2 -1 is 0, and this drawing is correct. There you go. Now, one more. We tried to find the NO3 negative ion. So we count up the valence electrons in nitrogen, which is 5. We count up the valence electrons in oxygen, which is 18. And we have this extra electron here, which gives us 1 more. So we add all that up and we get 24. Now we're going to try to see how we're going to write the bond, the molecular molecule for this. And it'll look like this. We have N, we have an O over here, we have O over here, we have O over here, and double there, which gives that 8. And we got 2 here, 2 here, 2 here, that's 8. 2 here, 2 here, 2 here, 2 there gives that 8. 2 here, 2 here, 2 here, but there, that's 8. So let's count them up. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Will not work. So I'm going to have to take away these, put a double bond there, and now I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Is that still 26? Well, you got to take away these 2 up here. That gives me 24. Now nitrogen has 4 around it. 8 around it. 2, 4, 6, 8. 4 single bonds. 2, 4, 6, 8. And oxygen has 2, 4, 6, 8. Over here, 2, 4, 6, 8. Oxygen, 2, 4, 6, 8. Whoop! Now, you're going to ask out there in the cheap seats, folks, what is going on here? Because oxygen has 1, 2, 3, 4, 5, 6, 7 electrons. And it should have 6. So what's happening? It has a negative charge. We look over at this one. 1, 2, 3, 4, 5, 6, 7. Should have 6. It's got an extra electron. That's a minus also. Now wait just a minute. Hold the phone. Let's look at nitrogen. We have 1, 2, 3, 4. It's supposed to have 5. So it has 1 fewer electrons. So that's a +1 charge. Well, if you add a -1, +1 and a -1, it gives you a negative charge. So in fact, this is an ion with a negative charge. So it's written just like this: nitrogen, double bond, single bond, oxygen, boom, 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 boom. Oxygen, oxygen, right, oxygen, 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 boom, 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 oxygen, boom, boom, 2, 4, 6, boom, boom, with a negative charge. I rest my case. Thank you very much. Stay tuned for more broadcasts.